So thank you everyone for coming here to attend our session. I know a lot of the other sessions are very focused on storage. We're gonna pivot a little bit into security in storage, so I hope that this is interesting for everyone here. We're gonna try to keep it not as outdated as NTLM, so just go with the flow with us and hopefully we'll get some good info out of this session today. So I'm Miriam, I'm a TPM at Microsoft working on the Windows authentication team, accompanied by Tanmay, who is the software developer that's working on this NTLM list project. So just quickly going through what we'll talk about. So we'll start by just a quick intro for those who may not be aware of what NTLM is, why it's insecure, where it's still being used, and then we'll deep dive into Kerberos, which is the more secure authentication protocol, and talk about the new features that we are introducing to Kerberos over the next year. And then how SMB can leverage these new features moving forward, and what organizations can start doing today and over the next few months to prepare for NTLM removal in Windows. So to kick us off, what is NTLM? Quickly gonna go through it. It is a legacy authentication protocol that goes all the way back to Windows in around the 2000s, early 2000s. It is known as a fallback authentication protocol. So if a client wants to access a resource, it connects to the server, and we can go through that flow here. The client would reach out to the server, wants to access some sort of resource. In this scenario, it's an SMB resource. Server would go back and say, who are you? Client provides this string that contains their username and password and a response to the challenge. And then server simply straightforward says, oh, okay, I know who you are, carry on. Here's access to the information that you're looking for. Very simple, very straightforward. But there are problems with this simple process. Problem number one, there is no server-client verification. So the client, when it's verifying to the server, it doesn't actually know if it's connecting to the intended server. And so there are scenarios which we'll go through where an attacker or a bad actor can intercept that connection between the server and the client. So that the lack of server-client authentication or verification is one of the main challenges of using NTLM. The other part is weak encryption. As you can see, the message is encrypted using HMAC MD5, and then the password is hashed into a secret key that uses MD4 algorithm. Both are pretty insecure because of the low output entropy, and so it makes it easier for attackers to guess the key or crack the password over a duration of time. So that's the second main problem with NTLM. And then lastly, the lack of server-client verification and the weak encryption can both lead to certain types of attacks like the relay attack. And so that's when the malicious server can intercept that connection and then either gain access in real time using the password that they're able to receive or try to crack the password later on. So that enables lateral movement, man-in-the-middle attack, obviously, all things that are very susceptible to NTLM usage. And so why are we still using NTLM? There's a few reasons. The reason that we're trying to get to as fast as possible is that there are scenarios where NTLM is the only option for authentication, and we'll go through those scenarios. Another reason is that people may not actually know that they're using NTLM or that they should be removing NTLM from their environment. So lack of awareness is also another leading reason to why we're seeing a pretty significant amount of NTLM usage as of today. So going into the scenarios, as mentioned, where we are seeing NTLM usage, some of them, these are not all of them obviously, but these are the more prominent ones that we're seeing are machine-to-machine authentication, when there's no line of sight to the domain controller, scenarios where local accounts are used, and then when the SPN or IP address is unknown or misconfigured. So then bringing in SMB into this story. SMB does use Kerberos, but there are scenarios like, as I mentioned, workgroup scenarios where the negotiation phase, which we'll go through in a little bit, fails to authenticate through Kerberos and falls back to NTLM. And so NTLM would be invoked during the negotiate or SSP step, and the client and the server would both agree on using NTLM. then the original flow of how NTLM is used would carry on. The client would get access to the resource, the shared file that they're trying to get access for example, and that opens up, again, opportunities for attackers to intercept these calls or gain access when they're not supposed to. All right, and so now that we do know that NTLM usage is prominent out in the wild, how can we start taking some steps towards NTLM removal in our environments? We're happy to announce that just earlier in July, I believe, we released the enhanced auditing, and it is on by default on Windows 11 24H2 and Windows Server 2025. This enhanced auditing supersedes the old policies that we had, where you could audit traffic to remote or NTLM traffic to remote servers and so forth, and it provides a lot more information onto what or how NTLM is being used. These can be viewed, the logs can be viewed either through the NTLM operational event logs or through PowerShell. And just to give an idea of what to expect in these logs, this is a snippet from event 4020, which you would see on a client, and then event 4023, which you would see on a server. You can see these logs on client, server, or within an entire domain. On the right-hand side, or left-hand side, the event 4020, the one with the green boxes, that represents a somewhat as secure as you can get, or like a positive NTLM authentication, because it shows you that NTLM v2 was used, which is a little bit more secure than v1. It shows you what app or service, so SSPI auth, is trying to access, or is presenting the authentication request. And then it's also showing you why NTLM was being used. Where on the other side, event 4023, it shows you, it doesn't show you a lot of that information. So a lot of the information is missing, and NTLM v1 is used, and so something isn't right here. And so it provides the admins with an opportunity to drill deeper, in the case that they see this event coming up on their machines, to dig a little bit deeper into what this authentication request was, why it's happening, who's trying to get access, and so forth. If you're interested in learning more, that link, and I'm sure this deck will be shared after, this link has the blog that has all the information about this enhanced NTLM auditing, how to get started with it, what to look for, what the results mean, and all that. So please do check them out if you're interested. And then the other thing that we'll ask is that if there are specific things you want to see in the logs that you think would be helpful, please do let us know. We're consistently making like improvements and iterations of the enhanced auditing to make sure that they're as beneficial as possible. So if there's anything that comes to mind that you're like, oh yes, I want to see this in the auditing, please do let us know, and we'll take that into consideration. All right, and then I'll shift over to Tanmay Hole, dig a little bit or move into Kerberos and explain how that works.
Hello everyone, I'm Tanmay, I'm the dev on the project. Now that we've seen so much about what NTLM is and why we want to move away from NTLM, the question then was, what do we move to? Because we do know that there are certain scenarios that only NTLM supports right now. Do we go with a new protocol, or do we use something we already have? And that's how we ended up on Kerberos. Before we dig into how Kerberos is going to fit into the whole space, let's just talk a bit about what Kerberos is. Kerberos has been the go-to authentication protocol in the enterprise space for a long, long time now. So it's been hardened, strengthened, thoroughly tested, and it has great security. And that is why we are going to talk more about Kerberos now. So Kerberos, unlike NTLM, relies a lot on tickets. Kerberos ticketing kind of works in 3 stages. In stage 1, a client who wants to access a service is going to first talk to the domain controller in the domain and ask the domain controller for a ticket that proves its own identity. Once Kerberos has that ticket, in phase 2, it's going to say, oh, now that I have this ticket, I can use this ticket to get a ticket to the service I want to talk to. So it's going to present its identity ticket and get a service ticket. And now using this service ticket, it can present the service ticket to the service and say, hey, I want to use whatever service you're offering. And this way, Kerberos is able to provide mutual authentication, and it's also moving away from using password-derived keys on a regular basis. But there are known issues with Kerberos that kind of restricts where it can be used. One of them is that you need access to a domain controller. To get your ticket, you want to talk to a domain controller and you want to say, hey, please give me the ticket. But if there is no domain controller, or for some reason you have network issues, or you cannot reach the domain controller because of a firewall, you cannot use Kerberos in those scenarios because you cannot get the tickets. And the other situation where Kerberos does not currently work is a workgroup scenario where a standalone device is trying to authenticate to another standalone device. But Kerberos works because of the domain controller, because domain controller acts as an authenticating authority where it can say, yes, I know this identity and I can give you a ticket for that identity. But in a standalone space, there are no domains, there is no domain controller. So you cannot get a ticket, and we cannot use Kerberos in those scenarios. So that is why we introduce IAKerb and local KDC into the picture. Before we get really deep into IAKerb and local KDC, I'm just going to give a very high-level view of what they are. IAKerb is an extension to Kerberos where it's gonna act as a wrapper around Kerberos and say, okay, I'm gonna help Kerberos be used in certain scenarios where the reach to a domain controller is restricted. And local KDC is kind of designed to act as an authenticating authority where it can talk to a SAM database on a given Windows instance and give out tickets for identities that are local. To dig a little deeper into what IAKerb will do for us, let's take an example scenario. So say there's a remote user working from home, and the company, whatever corporation they work for, has a public-facing corporate server. But to access the service, the user has to authenticate to the service. But for some reason, they're having VPN issues. So they cannot reach the domain controller because the domain controller is behind a firewall and the VPN is not working. They cannot get the ticket. The only way things can work right now for them is use NTLM to authenticate to this service. But when IAKerb comes into picture, IAKerb is going to make this service act as a proxy for Kerberos. So now the client can tell the server that, hey, I want to use IAKerb. I cannot reach the domain controller. Can you reach the domain controller for me? So in this instance, the server is going to forward the client's messages to the domain controller that's behind a firewall. And it's going to act as a middleman to help the client get a ticket. And once the client has a ticket, the client can present this ticket to the service and continue with its Kerberos authentication and gain access to the service. Here, which was clearly an NTLM only situation, we introduced Kerberos into it and made Kerberos work. Thus, we reduced the dependency on NTLM. And let's talk about how local KDC can be used. Usually, in a standalone environment where it could be a workgroup scenario, a cluster scenario, authentication in these spaces so far has worked something like, I have 2 or 3 devices. I'm going to set up the same user account on all of these devices with the same username and password. So if there's any authentication required between these 2 devices, NTLM is going to generate the same hashes and key material, and authentication is going to succeed. How do we take away NTLM from this scenario? We are going to say every Windows instance is going to run a local KDC. Now, this local KDC is going to interact with the SAM database that is on the given Windows system. That way, it has access to what the local accounts are. And when the client tries to authenticate to a server, they have the traditional cluster setup or a workgroup setup. So they have the same username and passwords on both sides. But now, on the server side, the server is going to talk to the local KDC internally, and local KDC is going to be able to mint tickets for this identity. And usual Kerberos flow goes on, and they get successful Kerberos authentication. Another major NTLM usage moved away from. Now, what is next for IAKerb and local KDC? So for the initial release that we have slated for sometime early next year, this is a tentative plan for how the release is going to look like. We will have a fully working IAKerb component to it, but local KDC has multitude of scenarios that it needs to cover and support, and every few weeks or few months we come across a niche scenario that NTLM is being used for, and we have to account for that and give and local KDC update. So the initial release is going to have fully functional IAKerb, some scenarios that local KDC supports. But every future update, local KDC is going to support more and more scenarios, and thus we are slowly moving away from the amount of NTLM users that's in the market. So at the end of the session, if anyone in the room thinks there's more scenarios that we should be thinking about in terms of NTLM users that are, no matter how niche they are, please let us know.
Cool.
Mariam will take over.
All right, so then now that we introduced what will be available in Kerberos, and knowing that there are those scenarios where SMB falls back to NTLM, we'll pivot to how Kerberos and SMB can work together. And so just reiterating some of the information in the context of SMB authentication, one of the main reasons SMB does, oh yes, better, okay. Do I need to repeat any of this or? Okay. Okay. No, you're fine, that was my fault. Yeah, so just reiterating, we'll shift into how SMB can be further hardened in terms of security with the enhancements we're doing to Kerberos. There's a lot of obviously sensitive data and information that flows over SMB shares. And so we want to make sure that whenever there's a client or user trying to access this data, that they are actually who they say they are and that they are connecting to the server that they are attempting to connect to. And so this requires stronger authentication, obviously, for SMB. The other thing, again, NTLM exposes those risks of relay or man-in-the-middle attacks and lateral movement, all of which can provide further access beyond SMB if someone were to gain access. And we're hearing what the customers are saying is that SMB is one of those prominent use cases that we want to make sure is secure in the future. And so with the enhancements in IAKerb and local KDC the IAKerb local KDC enhancements we're doing with Kerberos, this will allow to expand the scenarios of Kerberos usage in SMB. Will provide that mutual authentication where the client and the server actually are legit and there's trust between the two. It'll integrate with AD or Active Directory for access control, and then to Summit, it just provides more secure storage in SMB. All right, so we'll go through this demo. Want to give a shout out to Ned for this demo. It'll show the current experience of how NTLM is blocked or how NTLM can be blocked in a local account scenario. So the first step will be to check the client settings and just make sure it's showing that NTLM is not currently blocked, so it should work. Cool. And then the next step would be to map a drive to the server, and we'll connect to the share using a local account. So we'll provide a password and username to access that. All right. And then to make sure we understand what kind of authentication happened here, we'll look at the logs, and you'll see in the negotiation phase that where authentication happens, you can see that NTLM is being used, and we can confirm that by digging into looking at the admin, seeing that they're using it is a local user using a password. And so now that we see this experience of NTLM being used, we'll block NTLM and test the experience there. So this just confirms that NTLM was not blocked, and then we'll block it. And then now we get this error when we try to authenticate, that the authentication failed because NTLM is disabled, which will happen here. Cool. And then just to confirm, looking at the logs, you can see that negotiate was attempted to use Kerberos, but then when it tried to fall back to NTLM, it failed because it was blocked and the authentication was not successful. So that's the scenario of a local account, where local KDC can jump in and help make sure that the authentication is successful using Kerberos and not fall back to NTLM. Now we'll shift into IAKerb enhancements and how that could be used with SMB.
So far, we've talked about NTLM, why NTLM is bad. We talked about what IAKerb is, what local KDC is. But now, how does this all fit into the SMB picture? Because yes, local KDC, IAKerb, they do great things with Kerberos, and they provide great options for us. But how do we integrate that back into SMB and say that SMB is actually benefiting from all of this, right? So that comes through a protocol called negotiate. Today, SMB, when it wants to authenticate, it's going to ask the Windows OS. It's going to say, hey, I want to authenticate to this server, but it's not going to tell us that, hey, I want to use Kerberos, I want to use NTLM. It's going to ask the Windows OS that, hey, use the negotiate protocol and please negotiate the best possible protocol for me. And what's happening in the in-market version of the Windows OS today is that negotiate is, SMB client is going to talk to negotiate, ask for the best protocol it can give. Then negotiate is going to see that, okay, let's see if Kerberos works. It's going to try Kerberos. In this hypothetical scenario, we're going to say we don't have line of sight to DC. So Kerberos cannot get its tickets. And then negotiate is going to say, okay, I'm going to tell the server that I only support NTLM because I cannot get tickets. So it's going to tell the server that, hey, I support NTLM. Do you do too? And the server says, yes, I do NTLM too. And let's do NTLM. NTLM auth succeeds. But what happens when we introduce IAKerb into this? Now, Kerberos authentication fails because we don't have line of sight to DC. And then the client says, okay, but I can still do IAKerb, right? So I'm going to tell the server I do NTLM and IAKerb and let the server tell me what it can do. And the server tells the client that, yes, I can do IAKerb too. Let's attempt IAKerb. And the attempt IAKerb, the client gets the tickets it wants, and it goes on and does the Kerberos authentication. This is all good. However, what happens here is that IAKerb needs some extra round trips to figure out if it can actually go ahead and continue doing IAKerb and get the tickets. The existing negotiate protocol only works in a way that it lets the client and the server try a protocol and then say, I'm either going to succeed or fail. It does not have a mechanism where it can support a scenario where IAKerb could say, hey, I tried doing IAKerb, but I could not do IAKerb. Can we move on to something else? That is not possible in the existing negotiate mechanism. That is why we enhance the negotiate mechanism to include something called late fallback. So what can happen now is, say, both the client and the server don't have line of sight to DC. What's going to happen now? The client is going to try to do Kerberos, cannot get its Kerberos tickets. It's going to ask the server if the server can do IAKerb. Server says, I can do IAKerb, let's do IAKerb. And then the server discovers, after a few messages were exchanged, that it could not reach the DC either. Now, the server has an option to say, hey, I tried IAKerb, but we cannot go ahead and complete this IAKerb transaction. Can we fall back to NTLM? And it does fall back to NTLM, and everything's good. But why? Why do we need to let it fall back to NTLM? Why cannot we just say, I'll let IAKerb fail. If IAKerb can't do it, I don't want NTLM. If we take that approach, what we're going to do is, as we release this product out the door, we're going to break a lot of customers, but who for some reason still cannot work with the existing or whatever the new features are. But if we give them the option and say, hey, we are giving you IAKerb, we are giving you local KDC, and these are going to seamlessly work with your SMB setup because Negotiate can do this late fallback thing. So we're going to try to give you Kerberos in these additional scenarios. And if they don't work, we'll give you NTLM still. Now it's up to the user to say, or the customer corporation or whatever, to say, we want to block NTLM. We're going to push out a policy to block NTLM. Having this option is going to make it a better adoption strategy. And it's going to give more confidence for customers to move away from NTLM as we give out more and more updates. So let's see how this whole thing can work with a demo. So I'm going to try to access a file share. This is a standalone setup, so these are two unjoined machines. And I said, don't use NTLM. And the Wireshark capture shows that something's happened and something succeeded. Now, if we look into the Wireshark capture, we will be able to see what the client advertised to the server. And in that advertisement, we're going to see that it advertised IAKerb. It advertises IAKerb, but at the end, it also says, I support NTLM. Now, let's see if we actually end up using NTLM. And the server says, yes, I can do IAKerb, I will do IAKerb. They exchange a couple IAKerb messages, they go back and forth, and eventually we're going to get to a message that says, oh, everything was good, I was able to authenticate using IAKerb, and authentication succeeds. We didn't even have to attempt NTLM in this scenario. But if push comes to shove and something fails because of IAKerb not being able to get the tickets, we can still fall back to NTLM because NTLM was advertised too. So just to summarize the whole thing, because I know I said a lot right now, we have SMB setups. SMB client and server need to talk to each other. And if this is a joined environment and the SMB client could not get its tickets, it's going to rely on IAKerb to help it get its tickets using the server as a proxy. And if this is a standalone setup where there is no domain controller, local KDC is going to help mint Kerberos tickets and enable Kerberos authentication. Now, what is the ultimate goal? We want SMB to benefit from all the enhancements that are coming into Kerberos, and that will come into Kerberos in the future as well. And as we continue to do that, we are going to reduce our reliance on NTLM gradually. And once we get to a point where we can conveniently say, okay, we don't really need NTLM unless an application hard-coded NTLM in its authentication. There, we cannot help them because they hard-coded it, and it's going to be a hard transition for them. But we do recommend that everybody use Negotiate so they can transition off of NTLM as soon as the OS supports it. And once we get to a point where we can say, okay, we are ready to remove NTLM from the product or disable NTLM in the product, that is when we can all relax, gain some inner peace, and watch some sunsets. Yeah, that's the goal. That's the goal. That is where we want to get everybody, and we want to say we are doing everything we can to get you off of NTLM, and we have done everything we can to get you off of NTLM. And now, talk more about what comes next.
So this is our last piece of information here to kind of wrap everything together. there are some ways that you can start to prepare to disable NTLM in storage or just in your environments, and that's by leveraging the enhanced auditing that we released to understand where NTLM is used, why it's used, start to disable NTLM, do some testing to figure out what could potentially break in your day-to-day workloads if NTLM was disabled. And then you can also preview IAKerb and local KDC on the Windows Insiders program. If you're interested in that, we do have a private preview program that's currently running. So you can always reach out to us and we can add you to that group while you get what version of Windows you need to be on in Insiders, and then all the instructions and any known issues we're aware of or bugs that we're currently fixing. You can get all these details if you're interested in joining. Yeah, that wraps it up. I think we have some time for questions. So if anyone has questions, please feel free to ask. I saw, yeah. I'll just be repeating your questions so that it could be heard on the recording, but yeah.
Can you go back to the slide with NTLM fallback?
With the one with late fallback or?
Yeah, that one.
Okay.
It's not really valid because between 5 and your success, the server needs to ask the DC. And yeah, what failure modes do you actually see where you can't get a Kerberos ticket, but do the net log on, SAM log on?
Isn't it the idea that Kerberos itself is broken, like bad search principal name? So if you did NTLM, it would work. The DC is available, it's just broken for Kerberos.
Yes.
What is the realistic scenario where
Bad SPN, duplicate SPN, that's historical nightmare constantly in the environment. So I would say just repeat.
Yeah, so just so everyone hears it, the question is, correct me if I didn't hear your question right. What is a reason IAKerb could fail to get the ticket in number 3? And what would tell us that if 3 fails, 4 could succeed?
Yeah.
Correct? And yeah, so a couple multi-phased answer to that. Kerberos can fail for a lot of reasons, like Ned says, bad SPN configuration. Sure. But we also classify internally what is a fatal error and what is not a fatal error. And a non-fatal error, for example, is the server says, I could not reach the DC. So the server is going to fail, and we attempt NTLM. Now, will NTLM pass, NTLM fail? Depends, probably specific to what the scenario is. But if NTLM was working before, it will continue working in this scenario too. But we have introduced IAKerb into the flow to better our chances of getting Kerberos authentication. Yes?
Is the local KDC mentioned at the end there a Windows component?
Yes. It is going to run as a Windows service.
The Windows service?
Yes.
So a non-Windows SMB server won't have a local KDC. That's a Windows only.
Yes, but a non-Windows SMB server is free to implement their version of it.
Right.
Yes.
There do exist such things, but
Yes.
in a lot of legacy environments it doesn't. So it's, I just wanted to be sure this wasn't some optional add-on.
No, it is not an optional add-on.
Makes sense.
Yes.
A couple of questions. Does IAKerb also require SPNs? But one of the reasons I see customers using NTLM is because they want to use IP and not. And then the next question is on slide 24. What is the relation to go with that?
24, you said?
24, yeah.
Okay.
What is the relation between the local ADC and the DC? Is there some trust relationship there?
Okay, 2 questions, right? Okay, the first question, could you remind me what the... Yes. How do SPNs fit into the picture when IAKerb is involved? So Kerberos authentication is not supported when an SPN is not properly configured, right? And how do we make it work? Because NTLM is the preferred authentication in that method. We do have plans to support those scenarios. They are not currently supported in the private preview we have, but that is a scenario that we have plans to support in a future update. And question number 2, how are local KDC and DC related? Local KDC and the DC in a given environment, they are not related at all. They have no relation. Like this diagram is expected to show like an equivalence of what the local KDC is acting as. So in reality, local KDC and DC do not have a trust, and they are not talking to each other at all.
Maybe was asking about that you can now do IP address with Kerberos and it would work. You don't care anymore, right?
In a fully completed product, it would work. But when we say we're going to support some initial scenarios and we're going to provide future updates to support more scenarios, it's going to be in one of the future updates. But yes, theoretically, it could work, and we will make it work one day. More questions? Yes.
Last year, presentation about IAKerb, Microsoft mentioned that it will be special command on the client to set up SPM metrics. Is it going to continue? So they said last year it will be no IT communication. To get IAKerb working, you need to still set up SPM, but local on the client.
I can get you more information on that because the design for it is still in review. So because we haven't finalized any design, I cannot tell you any more about it.
Where is the SPN configured? If an SPN is required and there's no connection to the Active Directory, so where is it configured?
On client, they show, at least last year, they show there will be special command which you execute on the client, which is set up SPM to the...
Technically, you only need SPN for more than one service. In the end, if you have a host, that's good enough for if you want to do like this. Yeah.
We'll do it on the server.
On the server itself. But we don't actually need it. We're not going to use it. It's amazing.
More questions? Sorry.
Knowledge of Kerberos to enough equal level. But if you announced that one of the advantages of Kerberos is that the server authenticates itself to the client, so the client knows exactly what server it's talking to. How does that work with local KDC? If there is no pre-existing whatever shared secret, does it work with local KDC, or is it in the local KDC case just as good as NTLM and basic?
So local KDC improves the usage in the standard. Sorry, to repeat the question, how does local KDC make it better than NTLM in a standalone device authentication? Correct? Is that the question?
And how does local KDC also have the feature so that the server can authenticate against the client?
Yes, mutual auth. So local KDC is going to have better encryption algorithms than whatever NTLM provides. And when it comes to mutual auth, I don't think local KDC is going to provide the same mutual auth that a domain controller does, but it definitely improves the security in a in a cluster environment or a workgroup environment. Yes, question.
Okay, so a couple questions. The first one is from the point of view of what you see on the wire. The main thing that it sounds like changes is nothing changes for the peer-to-peer Kerberos example, because SPNego still is negotiating Kerberos, and so nothing is different in SPNego. But for the IAKerb case, you have a new OID that you had to have registered somewhere, and presumably we can find that somewhere, the new OID. And I'm assuming that in terms of priority order, you pick Kerberos first, if both client and server agree Kerberos is there, and IAKerb is second class. Because obviously peer-to-peer Kerberos would be better. But what concerns me a little bit is cases where Kerberos security can be worse than NTLM V2, where depending on the crypto algorithm that's negotiated, right? So you'll see, for example, with FIPS, certain things when Kerberos is disabled, there's new Kerberos, crypto, whatever flags and fields. Is there ever a case where IAKerb would be negotiating a stronger crypto than Kerberos, and we really should be flipping our preference on the client to which one we choose, even though normally we would say, if Kerberos is supported on both ends, we use it. If IAKerb, all that. But there could be a case, I would think, especially with IAKerb, where the domain controller is being forwarded to supports stronger crypto algorithms. And is there a way to sort of sanely pick the best IAKerb versus Kerberos, even if the ordering in SPNego is backwards?
Okay, just to summarize your question. When we are advertising, when a client advertises its supported algorithms, supported mechanisms, it's going to say Kerberos, IAKerb, and the rest of the things. The question is, can IAKerb in any scenario give you better crypto than Kerberos does? And if so, is there a way to pick IAKerb over Kerberos, to say first try IAKerb and then try Kerberos? And to answer that question, IAKerb is going to get you the same crypto whatever Kerberos can get you. But we have hardening happening on the Kerberos, and so whatever security Kerberos can provide you, IAKerb is going to provide you the same level of security, because under the hood, IAKerb is still doing Kerberos. IAKerb is just a wrapper around Kerberos that extends Kerberos' reach to get to the domain controller. So to answer that question, no, IAKerb cannot get you better crypto than Kerberos can, but
Clear. So
yes.
For example, let's say 256, whatever is supported by the domain controller that you can't see. IAKerb, though, will be using the 128, the same as Kerberos to peer-to-peer example would be, even if it
Just a simple example. Yeah. I mean, there was also the like UDP.
Yeah. So even though the domain controller, if you have line of sight to it, would support stronger Kerberos, you don't have line of sight, so you're ending up defaulting to the lower for both IAKerb and Kerberos because you're going to a target that only supports 128.
So the target does not get to see or unpack whatever messages that Kerberos is sending to the domain controller. The target server is just acting as a proxy. I take something from you, I give it to the domain controller. I don't know what's in there. So whatever negotiation can happen between the domain controller and the client for Kerberos crypto will be the same unless somehow you have domain controllers that are of lower grades.
Newer and supports, let's say, 256, where your peer-to-peer target that your server target, like the old, only supports 128. That was the example I was thinking of.
Yeah, I don't think that changes the security that Kerberos and IAKerb can provide for you.
It's just a proxy, they wouldn't know,
Yeah.
care. They wouldn't care. Well, unless it was a local KDC itself.
That's kind of what I'm getting at, is that
The local KDC is going to be using AES-26 because it's a brand new.
Yes.
It's not going to be RC4 or anything like that.
I guess what I'm getting at is if the local KDC didn't get updated for 3 years, but the domain controller was, there might be a case where a newer.
I mean, yeah, there's a possibility that you could have a gigantic fleet of older gross KDCs, local KDCs someday. In fact, that's what you'd like to do. Maybe they're just not maintained as well as the DC and DCs.
Oh.
That's all I'm asking.
One unrelated question. The other thing that's confusing is that in the Windows space, there were some important things the client needs to be aware of in the pack, in the private data area. Sometimes you'd have owner information because they got they're very useful in the private data area. And this was nicely documented in some obscure protocol documents. Is the pack, the private data area, containing anything new or interesting for either of these two new cases?
At the moment, no. More questions? I saw hands. Yes.
How does it detect the IAKerb service? Let's say client tries to reach DC and it is like not reachable and then calls back to IAKerb. What is the response? Where is this being given to the client?
So this is the internal mechanisms, what Windows does. At boot, Windows is going to negotiate what all packages are configured on it. And if it's a newer Windows, it's going to tell, hey, I do Kerberos, I do IAKerb too. And now the client gets to advertise that to the server negotiate. And the server negotiator is going to take a look at that and compare it to whatever it supports.
IAKerb supports the cluster domain authentication that gets Kerberos to itself. And how does that work? Will that be, in general, Kerberos cluster domain case, client will be redirected to the target DC, target domain of DC. In this case, IAKerb still runs the ticket to the
Yes.
target DC.
Yes.
Can you
All right.
repeat the question?
Oh, sorry. The question is, how does the IAKerb discovery work? And how does the client know that it can do IAKerb in the first place? And the answer is, each of the security packages on the Windows OS is going to report to negotiate what it does at the start. And now negotiate knows all the protocols that it can do. Yes, not every Windows version will be able to do IAKerb unless it's updated.
Are there backward plans?
Potentially.
Unsure.
Potentially, but not currently planned for.
Any more questions?
I just wanted to, I think might have been you about Kerberos not being secure. There are also active work that we've also announced in the Kerberos space to make it more secure, including the encryption algorithms that are used to be more compliant with post-quantum. And so given that IAKerb won't work without Kerberos, whatever enhancements we do in the Kerberos space will apply to the bridges that we're building to enable more Kerberos usage too. Yes, there are plans to do that. Exact dates have not been publicly announced yet, but it will be over the next 2 to 3 years, perhaps. And that's, just to emphasize, that's to disable NTLM, but complete NTLM removal is still a few years away. Yeah.
I thought NTLM V1 was disabled a long time ago. So it's only when you're saying NTLM, you're meaning NTLM V2, right?
Correct.
I think NTLM V1 was disabled 100 years ago.
Correct. It is disabled, yeah.
All right, if there's no more questions, thank you so much for attending our presentation.
Thank you.